And second half class, we'll try to get through as much of 2.4 as we can. Then I think we'll be in good shape. Okay, so the first thing is, now you don't necessarily have to write this down because this is what we talked about last time. That's what we call the vertex form of a quadratic function. And we're going to write the equation given the graph. So the key thing is to know what the vertex is, okay? So we're going to write equations for this. So first of all, let's on this one. The vertex is right here, okay? So that point is over 2, up 1. So the vertex is 2, 1. Okay, so that's what you got to know on that. So what I would recommend you do when you're doing these problems is just write down the formula, which is y equals a x minus h squared plus k, and just put the vertex in. Okay, so the 2 goes there, and then the 1 goes there. Okay, that's what the vertex is. Okay, now let me ask you this question, see if you caught on to this. This parabola goes upside down. So what has to happen there? You have to have a negative, right? Okay. And also check this out. If there's no stretch or shrink, you know that because you're going over 1, down 1. Okay, that's a good point. Or over 2, down 1, 2, 3, 4. There's no stretch shrink for that fact. So just over 1, down 1, over 2, down 4 means that's negative 1. Okay, all we're going to focus on these mostly is graphs that don't have stretch shrink on them. Okay, so the answer to this problem would then be this. We would just say y equals, and you can put just a negative or a negative 1, it doesn't matter, x minus 2 squared plus 1. Okay, that's the equation for that particular graph. So what you got to do is get the vertex, then figure out what a is. Okay, and a is always going to be 1 or negative 1 depending on how it orients. Okay, okay, what does it look like the vertex on this one is? What do you think? Over 1, how far down? Does that look down 3 to you?
Yeah.
Okay, so that's your vertex. Okay.
Brad, not to cut you off, but is that a K on A?
Yes, this right here is a K.
That is a K.
And this right here is a K. The general form is ax minus h squared plus k. All right. Okay, so again, what I'm going to do is I'm just going to plug in. The formula is y equals a x minus h squared plus k. So plug in the 1, that's the x value of the vertex. Plug in negative 3 for k. All right? All right. Now, look at this right here. Is that going to be positive or negative since the parabola is going up? That's positive, okay? And also notice on this, over 1, up 1. Over 1, up 1. Okay? Over 2, up 1, 2, 3, 4. So that looks like there's no stretch or shrink on that since you're over 1 like that. That looks fine, okay? So what we'd have for the answer then is we would just have this. We'd have y equals, and you can put a 1 or just leave a blank if you want to. The key thing is it's positive, so you'd have x minus 1 squared, and then instead of plus 3, you would have minus 3. That's the answer. Okay, locate the vertex and plug it in, and then a is positive or negative depending on if it opens up or down. Okay, is everybody with me there okay? Okay, all right. So that's just kind of doing these backwards. You want to be able to graph these, and if you're given a graph, want to be able to tell what that function is by using this formula, okay? All right, let's go to the next page here, and I'm going to let you try maybe a couple of these and see what you get, okay? So if you want on these, if you need to, just write down the formula, okay, that we're doing, and all you got to do is find the vertex, plug it in correctly, figure out if a is positive or negative, because a is going to be 1 on these problems. I'm not testing you over when they're not, when a is not 1, okay? So just see if you can get the answers on these two. And then we'll kind of focus a little bit from here on some graphing calculator stuff for a little bit. So let's see, what's the vertex on the first one? Negative 2, negative 4, right? Okay, so that means that's going to, the negative 2 goes there, the negative 4 goes there, okay? Now when you do this, you're going to go up. So is A going to be positive or negative? Positive, because we're going up. Okay, so it's positive 1. So you would have y equals, you can put 1 or leave 1 off. Then it would be x minus negative 2. This is where you got to be careful. Minus negative 2 would become plus 2. Okay? Then if you plug in the negative 4, you'd have minus 4 like that. Okay, so that is the answer to the problem. Okay, another way to look at this is like this, like we've learned with transformations. You can tell this thing is moved to the left 2. That's what that does. And it's moved down 4. That's what that's done. Okay? So that's minus negative 2. That's why I get the plus. Yes? What's that? The vertex? Okay, the vertex is just the point there where it comes together. So just find its x value and its y value. The x value of that vertex is negative 2. The y value is negative 4. Okay? That's the whole key to do these problems. You've got to know what the vertex means and what that is at. Okay, what's the vertex on the second one then?
3, 2.
Okay, it looks like over 3 and up 2. Okay, so it goes like that. So again, if you plug this in, it would just go like this. It would be y equals, and you'd have a negative because it's opening downward, so you'd have negative 1 or just negative. Then it would be x minus 3 squared, and then plus 2. So again, what I'm doing is just plugging in the h, which is 3, and the k into that formula, so that would be the equation of that parabola. Okay, are you with me or not? Okay, find the vertex and plug it in, okay? And then if it opens up, a is 1. If it opens down, otherwise a is negative 1. That's it. Yes?
Second one, y equals negative 1. Why negative 1? Because it's down?
Because it's going down, exactly. Yeah, okay? That's just kind of looking at your transformations. Those are all the little details. Okay, any other questions? Okay. All right, now we're going to do some stuff on this next stuff. We're going to do some graphs with and without our calculator. So to begin with, I think most of these things I'm going to put in just to start with on the calculator. So we're solving what we call a quadratic inequality, and we're going to go like this. I'm going to go to y1. If you brought your calculator with you, just put it in the way it is. You don't need to FOIL it out. You just go y1 and you go x minus 2. And then new parenthesis, then just say x plus 3. And then we'll do that in a standard window. All right. The fastest way to get to the standard window is to go zoom number 6, and then that'll graph that in a standard window for you. Okay. All right. So you want to get the y equals in, and then just do a zoom 6 for a standard window. All right. Everybody with me? Okay. Okay. Zoom 6. Now what we're going to do is do our table and just get some points here. Okay. So if you get this in your calculator, you have a table that's above graph, so you can go second graph. There's a table, and then you got a bunch of points. Okay, so what we're going to do is just find some points. Can you guys see those numbers okay from where you are? Okay, so I'm just going to use some of these points on here and just have you plot some of these points. Okay, so I'm going to start with...
hold on, Brad. So after you had x minus 2 and x minus 3 in parentheses, what did you hit after that?
Okay, what I did next was I went zoom.
Zoom.
Number 6. Okay, that sets up the window for you so it's standard. Okay, so it goes like that.
Okay.
And then there's your graph. All that does is makes the window go from negative 10 to 10. Now your table, we go second graph. There's your table of values, find points, and start plotting them. Okay, here's negative 4, 6. So let's just put as many points on as we can. There's negative 4, 6, and so forth. Okay. All right. So just get enough points. I see negative 3, 0. I also see 0, negative 6. And I also see... What?
How did you get that window from the parabola?
Okay. All right. One more time. Go like this.
Second graph.
There you go. Second graph. Okay. You guys got to get this stuff down. Okay. All right. Now you can just kind of connect the dots on this. That's good enough. Okay. Just got some points. I plotted enough points to get the details. Goes like that. Is everybody getting a graphing calculator? Hope so, because you're going to need one for your first test. Okay, now what we're doing from here is we're doing a less than problem. Okay, less than means you're going to look at all of the values that are below the x-axis. Okay, like that. So we're going to just give a solution to this inequality like this then. All right. So what we would have then is you put in your calculator, like I've already shown you, x minus 2, x plus 3. All right. Now the solution is just all the numbers between negative 3 and 2. Okay, that point right there was the point negative 3, 0. This point right here was the point 2, 0. Okay, so in set builder notation, we would say, since it's less than, we would say the set of x, and then we would say negative 3 is less than x is less than 2. Okay, because what you're doing on this is you're just identifying that less than means where is the graph below the x-axis. That's what that means. Okay, if you do this in an interval, in interval notation, then what we'd have is we would just say it starts at negative 3, ends in 2. We would use parentheses because it just has a less than. It doesn't have less than or equal to. So that one's one that I want you to do with your graphing calculator to start with. Okay? All right. Are you with me? Less than's below. What do you think it means if it says greater than? Where's the graph above the x-axis, right? Okay, that's what you got to understand. Okay, so on this one, let's start this one without the calculator to begin with. So we're going to factor this. And what we're going to end up doing by doing this is we'll kind of find where our x-intercepts are. Okay. So with this one, we're going to factor that. Okay, so the first term is x squared. So that means that would go x and x. The last term's 12. What would you use for 12 when you factor this? 4 and 3. How come 4 and 3? Because you want to add the 7, right? Okay, so we'd have a 4 and a 3, and we'd have 2 plus signs like that. Okay, so it's already in a factored form now. And then what you'd want to do is just set each of those factors equal to 0, like we've learned how to do with the quadratic equation. Solve those two equations, which you can do in your head. And that would give x is negative 4. And then same thing here. You don't have to write the step because you can do that in your head. You'd get x equals negative 3. Okay? Now what I'm going to do is I'm going to show you what's going to come out on the calculator. And so you can do this pretty much without a calculator if you want to. So what I'll have you do now is just go to your graph, put a dot on negative 4, put a dot on negative 3. Okay, what I just did is I just found the x-intercepts. Okay, like that, by factoring. Now let me ask this question. Because that's a positive x squared, is the parabola going to go up or is it going to go down? It's going to go up. So what I'm going to do is just kind of sketch a parabola that does that. We don't need to do this on the calculator necessarily to finish this up anyway. So just do this. You know the parabola is going up, and then you know it's going to go down kind of like that somewhere. If you want to put it in your graphing calculator, you can, and you'll get it more exact, but that's good enough. Okay? All right, this is a greater than or equal to problem. So tell me what I'm looking for on my graph. Above or below? Where it's above. Okay, so this time the answer is going to be these two places where you're above the x-axis. Okay, so where you're above the x-axis on this, if you do this in set builder, you would say below negative 4. When you're to the left of negative 4, your graph's above. So we would say x less than or equal to negative 4. Or when we're bigger than negative 3. So when x is bigger than 3, you're also above that graph like that. Okay? Interval notation is going to go like this. Okay, if you're to the left of negative 4, you'll say negative infinity to negative 4. You have a bracket because it's got the equal to bar. Then you would say union, start with negative 3, and go to infinity. Okay, you have to understand how intervals work to write your answer on this. But the idea is if you're to the left of negative 4, where's your graph? It's bigger than 0, right? It's above 0. If you're to the right of negative 3, where's your graph? It's above. Okay, so this part right here is to the left of negative 4 is this, and then to the right of negative 3 is that. Okay, does that make any sense? I can't tell. You got to know how to do intervals to understand this, period. You also got to know how to do your graph either with the calculator or without to just see if it's below or if it's above. Okay, that's the whole key. Yeah.
So you invert that, like you do the x minus 4 thing to get your sub builder notation?
Say that again.
You use that like setting that x plus 4 equals to 0, you use that for this.
Right, exactly. Yeah, so what's kind of happened on this is, you know, you're just seeing that when you're to the left or when you're less than -4, that would be one region that's above, and then if you're to the right of -3. Okay, just name them like an interval like we learned how to do when you're solving an inequality. Yeah.
You could do that step on the first problem too and get the same thing?
Yes, absolutely. So that one right there is, it's already factored. So if you set each to 0, that would give 2. So notice we had a x-intercept of 2. The other one, the solution of that's -3. So you do the same thing, and on that one, if you FOILed it out, you would end up getting a positive x squared, which would tell you it's going up. Okay, so yeah, you could do the same thing on that. You don't actually have to have a graphing calculator to do these. It's helpful, but you don't have to have one. Okay? Okay, so let's see. Let me do one more here. Okay, I'm going to try to do this independently of the calculator on this one. Okay? All right, so this one we have x squared minus 4 greater than or equal to 0. Okay, like the last problem, let's factor this. Okay, how does x squared minus 4 factor? X plus 2, x minus 2. That's the difference of two squares. Okay, you got to get automatic when you start seeing this now. So that's going to be x and x, 2 and 2, with a plus or minus. So that's your difference of two squares that we've talked about. Okay, now you can do this in your head. You just set each factor equal to 0. So what would be the answer to those two equations? -2 and 2, right? Okay, right? Show the work if you need to. So that's x equals -2. Add 2 here. Get x equals 2. Now what we get is those are x-intercepts. So here's all you got to do to solve this problem. Put a dot on 2 and put a dot on -2. That's it. That's the factoring part right there. Now let me ask this question. Okay, that's a positive x squared. So does the parabola go up or does it go down? Goes up. That's all we care about. You don't even have to get the rest of your graph accurate. All you really care about is we know it opens up. So then what you would do is just kind of sketch it in, kind of like that. And then below it'll have a vertex somewhere, but we don't care where. It doesn't matter. Okay? All right. Now what kind of problem is this? This is a greater than or equal to problem. So what am I looking for if it's greater than or equal to? Where it's above the x-axis, right? You're going to be above here, and you're going to be above there, not there. That's where everything is negative, okay? So what you would do here then is, like I've been doing, I just sort of shade where my answers are. That's where you're above the x-axis, like that. And then if you do this in set builder notation, it'd go like this. This is the background stuff. I'm not sure if everybody understands or not. So what we're doing is we're less than -2. When we're less than -2, the graph's above. So we would say x is less than or equal to -2. Where's the other place? X is greater than or equal to 2. Right. That's what I can't tell if everybody's. A lot of you have a lot of background issues with inequalities and stuff, so it goes like that. Okay. All right. How do you write x less than -2 in an interval? If it's that way, what do you start with? -infinity, then the endpoint. So you say -infinity, -2, and then how about the 2? Starts at 2, then where's it go? This way. So that is bracket 2 to infinity. Okay, like that. All right, and that's the idea.
On that negative, on the first -2, correct?
What's that?
That is a bracket on the
Yep.
first -2?
Yeah.
Okay,
yeah.
just making sure.
Yeah, these are both brackets because of that.
Yeah, it just looked kind of like a
Like I didn't write that very good, did I?
It's
okay.
all good.
Okay, all right. So that's it then. Okay. So try to do just one of them yourself. Try to factor this. You don't have to have a calculator to do this one. If you've caught on to what I'm talking about, then try to go through and do the factoring. Just kind of sketch a graph. Think about whether it opens up or down. That's all that really matters, is whether it opens up or down. See if you can put it together, okay? I'll give you a couple minutes to see if you can get this one put together. If you're having trouble with this, it's either factoring or maybe possibly the writing things in an interval or an inequality. That's kind of some of the stuff that you got to work on. But of course, you can put it in your calculator if you want to. So if you wanted to, you could, just put in x squared plus 6x minus 7, and you'll get a graph. Okay, do it in the standard window, so you can do it that way if you want to. Okay, has anybody got their X-Intercepts yet?
-7 and 1.
-7 and 1. Okay, how did this factor? You got x and x, 7 and 1, with a plus and minus. Okay, that's how you should have factored that. Okay, then once you get that, you can do the X-intercepts in your head if you want to. You'd have x plus 7 is 0, x minus 1 is 0. Okay, so that's going to give x equals -7, and that's going to give x equals 1. Okay, so you have to factor, and otherwise you can just go on your calculator, but I'd like you to know how to do this without a calculator. Okay, so what do you do with that -7 and 1? Those are your x-intercepts, so what you should have done is put a dot on -7 and a dot on 1. Okay, does this graph open up or down? It opens up. Everybody with me there? Okay, x squared's positive. So what matters, it doesn't matter how accurate it is, it's just going to open up, and then in between -7 and 1, it's going to kind of come together like that. That's a rough sketch. That's not a perfect graph, but it doesn't matter. Okay? Okay, now tell me, what are you looking for on this problem? Where it's above or where it's below? Where it's below. How come? Less than. That's a less than. So what that means is in this problem, your answer is going to be between those two numbers. So the next hurdle you got to get past is, do you know how to write these in an interval and everything? So the way you write this in an interval is like this. So your interval notation's real simple. You just say it starts at -7 with a bracket, and it ends at 1 with a bracket like that. Okay, it's just simply between -7 and 1. All right, doesn't have the infinities. And then your set builder, you would say set of x. And if you do it this way, you have to say x is in the middle of -7 and 1. So you write that as -7 less than or equal to x less than or equal to 1 like that. Okay? So you got to know how to write those things in intervals and in sets. Okay? So what did you have to know? Factoring, number 1. X-intercept, number 2. Does the graph open up or down? And then know, since it's less than, that you're shading below. And that's a matter of getting that answer written correctly. Is there any questions about that? Everybody okay? Okay. All right. Okay. So we're going to do, the next thing we're going to look at a little bit is we're going to move on and do some things with the quadratic formula. We hadn't done too much of that, but you want to be sure that you know how to handle this. So with this one, what we're going to do is, I'm given this thing right here. This one would turn out it wouldn't factor. Okay, so we're going to have to use the quadratic formula on this. So first of all, when you find a y-intercept, and we've gone through this a lot, when you find a y-intercept, you let x be 0. Okay, all right. So what we're going to do is just take the function that I gave you, and then you're going to solve this for x. So we've already got that. Okay, then on the x-intercept, what we usually do is we set the function, or the y value, equal to 0 like that. Okay? So what we're going to do first of all is, I'll kind of do this just at the side. If you look at this, we would have, you could think of this as f of x equals 2x squared minus 3x minus 8. Now I've given an equation. Now you can learn to do a y-intercept in your head. When you do a y-intercept, everywhere you see an x, just plug in a 0. Okay, so in other words, what you're doing is you're doing f of 0, so that's going to be 2 times 0 squared minus 3 times 0 minus 8. Okay, what's the answer in your head? Negative 8, right? All the zeros go to, everything goes to 0, so you'd end up having 0 minus 8, so that's negative 8. Okay, so the y-intercept, when we write that as a point, we say, okay, the y value is negative 8 when x is 0. Okay, so that's how you find the y-intercept. And you can, on a quadratic, you can do that in your head. Okay, x's go away when you replace it with 0. Okay? Now, what's going to happen on this when you find the x-intercept, you're going to find that this thing doesn't factor. Okay, so we're going to go do the quadratic formula on this. So basically, in this problem, we have the equation. To begin with, what we have is 2x squared minus 3x minus 8. So you got to know what everything means. A is going to be the number in front of x squared, so that's 2. B is the number in front of x, so that's negative 3. And then C is the other number, so that's negative 8. Okay? And I've written down the quadratic formula, so we're going to use this and plug into this when we do this then. So here's the quadratic formula that'll solve the quadratic equation if you can't factor it. So what you're going to have is x equals negative b. Okay, now b is negative 3. So we would say negative 3. Then you have plus minus. The formula says plus minus. Then it's b squared. So you do negative 3 squared. And then 4 times a. A is 2. And then c is negative 8. Okay, and that whole thing is all over 2a. Okay? So again, when you get the quadratic formula put together, just figure out what a, b, and c is, and do exactly what the formula tells you to do. Okay? All right, so a couple of details on this. If you have this part, what's negative 3? That's positive 3. Okay? So we got that. Okay, what's negative 3 to the second? 9. Negative 3 times negative 3 is 9, right? So that's 9. Okay, be careful when you do this part. You're multiplying two negatives. So if you do that part that I highlighted in yellow, that's just 4 times 2 is 8. 8 times 8 is 64, but it's 2 negatives, so that would be plus 64. And then the denominator, 2 times 2 is 4. Okay, like that. Okay, and then we're just going to add the numbers under the radical to get 3 plus or minus, and then 64 and 9 is 73. So that's what you get, okay? And see, it doesn't factor. You got this weird answer. The square root of 73 is a bunch of decimals, so you leave it alone. So the way you would write your x-intercepts is you'd write it like this. The first one you would say is 3 plus radical 73 over 4, and then 0. When you have an x-intercept, y is 0. The other one would be 3 minus radical 73 over 4, comma 0. That's what you do if something doesn't factor on a quadratic, because you have to put it in the quadratic formula. Okay? I think maybe we did that one time this semester for a different reason, so I did want to go through one where you got to do the quadratic formula. And my experience with that, students usually do fine on the quadratic formula as long as you know it and know what I mean by A, B, and C. Then it just really is arithmetic that you have to get down. Does that make sense? That's the formula that you were asking me about last week, yeah. Now that's the one that there's a song, Pop Goes the Weasel, and a thing like that. Okay? Yeah. You might have one of those. Some of them, the more modern calculators will have that in a calculator, so you could just input A, B, and C, and then it should. That may give you a decimal. I don't know on your calculator. Does it give a decimal? That's what I thought. You want to get the exact answer without the decimal too. Okay. Okay, so let's see. Let's do one more thing on here. And I'm not going to do the graph on this. So I want to do one more kind of like this where you have to possibly use the quadratic formula on. Okay. Now I do want to kind of give you a chance to do the quadratic formula one time in class today. So let's see, this one we're going to find the y-intercept. So we're dealing with this quadratic function. Okay, so a good thing to write down is just f of x is equal to 7 plus 2x minus 3x squared. Okay? What do you do to find a y-intercept? It's always the same. X goes to 0. The opposite variable goes to 0. So you're going to just replace all of the x's with 0. And then you can do the arithmetic on this pretty easily in your head. Okay, what's the answer? 7. Okay, so that would be 7 plus 0 minus 0. Okay, so you just get 7. All right. So our y-intercept would be the point 0.07. You found the y value when x was 0. So that's how that goes. Okay. All right. Now what we're going to do on this one is we're going to do the quadratic formula again to find the x-intercept. So with this one, a good thing to do, you don't have to do this, but it's a good idea to put it in the standard form where you write your x squared first, then your x term, which is plus 2x, and plus 7. All I'm doing is just turning things around, so I have ax squared plus bx plus 7. Okay? All right, so in this problem, what is a? Negative 3. What's b? 2. What's c? 7. Okay, so we got that. All right, so a is the number in front of x squared, b is the number in front of x, c is just the number. Okay, so let's see, I'm going to write down the formula. You don't have to write it down if you don't want to because it's on the previous page, but we're going to plug in the a, b, and c into this formula and just work out the details and get the x-intercept that way then. Okay, so it goes like this. We would have negative b, well b is 2, so that would be negative 2. Then we have a plus or minus. And then under the square root, we got to do b squared. B is 2. I just recommend you do parentheses squared. Then it's minus 4ac. A is negative 3. C is 7. Okay, so just do 4ac. Okay, and then it's one big fraction bar. It's all over 2a, so a is negative 3 like that. Okay, so that's everything set up. And then what you got to do is just work out the arithmetic. So you'd have negative 2 plus minus. Most of this you can do in your head or use your calculator to help you. That would be square root of 4. Okay, and then this part right here, you could take your calculator. That is 2 negatives again. You have a negative 4 and a negative 3, so that's positive. And let's see, that would be 12 times 7, I'm pretty sure is 84. Okay, and then the bottom is 2 times negative 3 is negative 6. And we're not going to do a lot of simplifying on this for this class, so this is just negative 2 plus or minus square root of 88 over negative 6. And for this class, that's going to be good enough. You could get decimals on that, and I'm going to show you kind of how to do this in just a minute. So I'm just going to write the first x-intercept is negative 2, and it doesn't matter which one, plus root 88 over negative 6, that's good enough, comma 0, and then the second one is going to be negative 2 minus root 88 over negative 6, comma 0, like that. Okay, so again, if something doesn't factor, you can still find the x-intercepts by using the quadratic formula. That's something that you want to know how to do. Yeah.
Will we ever have to get that equation into standard form and then do the quadratic formula, or would it always be?
Probably it will be. I mean, unless you have like terms and stuff like that. It may be something like the problem I just did where I had to kind of rearrange it.
But you never have to do another thing to get it into standard.
No, probably not. Probably not here. All right, so that's the idea.
But you could theoretically get, if you had something in a different form, you would just get an equation to move it into.
Right, you'd probably collect like terms, stuff like that. Right. These are all pretty standard in this class. Okay, so let's see. Let me have you guys try this one. And again, when you do the y-intercept, we have the function f of x is 4x squared minus 3x minus 8. Okay, and remember what you do on an x-intercept is you set x equals 0. That's the easy part. And then you got to use the quadratic formula for the x-intercept. So I'll write down the quadratic formula. I don't think everybody knows that, but just figure out what a, b, and c are. And then you can plug into the formula. I'll give you a couple of minutes to see if you can crunch that out okay. So what's your Y-intercept? That's the easy part of this problem. -8, right? Okay. So what do? You replace all of the x's with zeros. So you shouldn't have any trouble doing an X-intercept on these. It's, as long as you know that x is 0. So that'll give -8. So your Y-intercept, make sure you write that as 0, -8. Write it as a point, not just -8. So it's 0, -8. How about the quadratic formula? I didn't work it out. What did you get under the radical, those of you that did that? What did you get? 1 what?
137.
I can't even hear today because I don't have my hearing aids in. Okay. Different answers? Okay, let's find out. Okay, A is 4, B is -3, C is -8. Okay, so you got to get that first. Okay, and if you didn't do this or get it the answer I get, just check what you've done so far. So we'd have -3, that's the negative B part, plus minus, and then under the radical you would have B squared, which is -3 squared. Then it'd be 4A, A is 4, and then C is -8. So step 1 is to make sure you got everything set up, and then 2 times A would be 2 times 4. Okay, and then the rest of it's arithmetic. If you can do your arithmetic, you got it made. So that part is 3. Okay, underneath the radical, you would have -3 squared is 9. Okay, this part that I'm highlighting in blue, is that positive or negative? Positive. There's a negative times a negative there, so that one is 16 times 8. I don't know what 16 times 8 is off the top of my head.
128.
Okay, so let's do that, and we'll get all finished up here. I'm not going to have you guys simplify on these too much. That'd be 16 times 8. It is a positive. So that's 128. Okay, so we'd have this, and then all over 8 like that. Okay, is everybody with me okay so far? Okay, now then you just do 128 plus 9, which is 137. So what you would end up getting here is 3 plus or minus square root of 137 over 8. How many people got 137? Okay, that's good. Okay, all right, so that's the detail of that. Is when you write your X-intercept like this, you would just say, and it doesn't matter which one you write first, I'll say 3 plus radical 137 over 8, comma 0, that's your first X-intercept. The second one is just going to be 3 minus root 137 over 8, comma 0, like that. Okay, all right. Now what I'm going to do on this problem, and you can do this on your calculator with me if you want to, but I'll show this to you just on one problem here. So if you want to do this along with me, you can. You could actually graph this quadratic. So you could put in y equals, you could put in 4 x to the second. Whoops. So 4x to the second, and then minus 3x, and then minus 8, like that. Okay, and then we'll probably just do this in a standard window. So remember, the way to do a zoom standard window is what? Zoom 6. Okay. So there's your parabola, and it opens upward. Okay. So here's a couple of things that you can check, and you can check you're right by doing this. Okay. If you do your trace button, if you type trace and then 0, okay, that's how you could verify the Y-intercept. So that Y-intercept's -8. Okay, what I just did, once I got my graph, is I just did trace 0, and that verifies that the -8's right. That's my Y-intercept. Okay?
Trace 0 using this.
What's that?
Trace 0 using this.
Yeah, just trace 0,
Okay.
and then enter. Okay, did it do anything? Now sometimes these things don't work. You got the, so you got a bunch of extra stuff in your calculator. That's why it's all giving you crazy stuff. So all you need to do is just have something on Y1 and not in the other place. You've got stuff all the way down the list. Yeah, God, man, somebody just really jacked that through calculator. Okay, so anyway, now we're good. Okay, all right. Now if I go trace 0, see how it's blinking on -8 now? Okay, you just had some extra stuff in there as well. Okay. Okay, so I just wanted to show you that, and the other thing that you can do too is you can try this if you want to. Okay, this would go like this. If you were to go through and just get a decimal on this, okay, you'd have to do this like this. So you would have to go 3 plus square root of 137. I'm going to change this to a decimal. Okay, so you'd have to do that. I'm just doing this first one. 3 plus square root of 137, get the answer, and then divide by 8. Because if you want to get a decimal on these, you want to be able to do that, okay? All right? Okay? I didn't do that right. So it'd go like this. 3 plus square root of 137. That just gets the numerator. Now divide by 8. I must not have divided by 8. Okay, so that would give, this X-intercept would be approximately 1.830, like that. Okay, then you do the second one. The second one, you just go 3 minus the square root of 137. Okay, like that. Okay, that'll give that. And then divide by 8. And then that'll give you the decimal on that. So that other X-intercept, the decimal answer is about -0.109 if you round like that. Okay, so there are going to be times when you might want to get the decimal answer. But what I was going to show you on this is this. So now that we have the decimal answer, you can go like this. You can type trace 1.83. So if you do trace 1.83, then you can see that it's blinking on the X-intercept correctly. So you can check and verify by doing that. You could also do trace -1.09, and then you would get the same thing. Okay, so you can tell you're right. Okay. All right, so you can, once you get the quadratic formula, you can use your calculator to get a decimal approximation. Okay, does that make sense? Is everybody okay with the quadratic formula? Okay. Okay, so let's see. I'm going to do one application just to finish this up, and then that'll get us through this section. Then second half we do 2, 4. So this one is kind of the business application that we're going to look at a lot. So this one you have what's called a price demand function given by that function. It says this is X thousand computers sold at a price of P dollars. Okay, so we're going to find the revenue function. Okay, so what's the formula for finding a revenue if you know the price? What? Does anybody know? Everybody's a business major, right? You do the number of items times the price. What's the number of items? X. What's the price? P. So the formula is XP. We've talked about that before. Okay, so you need to know how to do that for sure. Okay, so the revenue is just going to be X times the price, which is 2,000 minus 60X, like that. Okay, then just multiply it out. Okay, so that would end up giving you the revenue function. We say R of X. Do a distributive property, that's going to be 2,000X minus 60X to the second. Okay, so that's your revenue function. If I give you the price, you multiply it by X, that gives you a function. Okay, we're going to graph that on the calculator. What does that graph look like? It's a parabola, but does it open up or down just by looking at it? Down. How do you know it goes down? Negative, because of that negative 60x squared. Okay, so we got to do this one on the calculator. You got this one. When you start doing applications, you want your computer to kind of take over. Okay, so the first thing I'm going to do is, if you got your calculator, just do this with me. We're going to go to Y1 and put in 2000x, then minus 60x to the second. So you want to get that put in to begin with. Okay, then we're going to have to figure out our window. Now, your job is to figure out the window. You have to learn how to do this. You know, if you're into business, you got to figure this stuff out. Well, the first thing I said was I wanted x to be between 1 and 25. So next thing is do your window. Okay, go to your window button and then put in, we're going to go 0 to 25. I don't want to start at 1, I want to start at 0. So let's go 0 to 25. A good way to scale that is by 5. So on a graph, we're going 5, 10, 15, 20, and so forth. Okay. All right. What is the lowest revenue possible? 0. Okay. Y is revenue, so that's 0. There isn't any such thing as negative revenue. Now, what you want to do to figure out Y max, you can either just pick a number. The best way is to look at your table. So if I go second graph, like this, just start looking at your Y values, okay? Look at this. You got numbers in the thousands, and it's going to get bigger for a while. So if I scroll down there, I'm starting to see numbers at 15,000, 16,000, and so forth, and it starts coming down. The biggest Y value that I saw was in the 16,000s. So for that reason, let's do this. Okay, when you do your Y window, go from 0 to 17,000. And then that should fit all of your data if you do that. Look at your table to figure that out, see. Then you can scale it by whatever you want to. I'm just going to scale that by 1,000 like that, and then you'll have a good graph. Okay, does everybody see how I figured out that Y? That table is what you want to do because you've got to figure that out. Now you should be ready to type graph, and you'll get a parabola. You want to make sure you see most of the whole thing. So that's good enough. Okay. Now for your graph, I'll kind of show you what I want you to do is just sort of a sketch on this. I'll just kind of show you what you want to sketch on your paper. So the first thing is if I'm having you do a graph, you always got to show what the scale is. So we're going by 5s out to 25. Okay, so you want to get that. If I say put your scale, then you want to do that. Okay, then the Y's are going to 17,000. You don't have to put every single thing on there. You can go like 1, 2, 3, 4, 5. That's 5,000. Then you can go 6, 7, 8, 9, 10. And you can even put a K. 10K is for 10,000. And then 15K like that. And then this is the X is basically this is X 1,000 computers. And say if I want you to do a graph on a test, you got to do this stuff. You got to put that stuff on your paper. Okay? And then the revenue is the Y value. So over here you just say revenue. And that's in dollars. Okay? You want to say what that's in and everything, of course. Okay? Now all you guys got to do is just kind of estimate points. It doesn't have to be perfect like this. So just kind of sketch in that shape like that. But the key thing is to have everything labeled like that. Okay? Okay, so what we're going to do then is we're going to find the maximum revenue, but we're going to do that algebraically, and I'll show you kind of how to do that. Okay? So this point, what do you call that high point on a parabola? What's the vocabulary? That's the vertex, right? Okay, so what we need to do is we essentially just need to find the vertex. And we're going to do this algebraically. We're not going to do this with a calculator. Okay? So one thing that we learned last time is the vertex can be found by using this formula, negative b over 2a. Okay, we spent a little bit of time in class using that formula, negative b over 2a, to find that. Okay, so the function that we have is we have r of x is equal to, now that's what I got highlighted in yellow. I'm going to turn this around and write that as negative 60x squared plus 2000x. Okay, so what is A and what's B in this particular thing? A is negative 60, B is 2,000. We don't care what C is because it doesn't matter. Okay, we're just going to plug in there. So what you want to do, and this would give you the X value of that vertex, is you would just do this now. Okay, so you would have negative 60, because B is negative 60, and then over 2A, okay, whoops, I did the wrong thing on that, didn't I? So B is 2,000. Okay, so A is negative 60, and B is 2,000. Okay, just plug those numbers into the formula. So what you would get is negative 2,000 over 2 times negative 60. And then we'll just use a calculator. So that's negative 2,000 over negative 120. And we can take the calculator, and that'll give the X value of that vertex then. Okay. Okay, so I'm just going to, that's 2 negatives divided to make a positive. So it'll be 2,000 divided by 120. So that's about 16 point, we'll just see 16.7. Okay, all right. So we have that, and then the other thing is we want to find the maximum revenue. So what that is that would be 16.7 thousand computers, because that's what it says in the problem. That's what the meaning of X is. So that's how many things that you have to produce in order to get that maximum revenue. Okay. Now, the way you find the maximum revenue is you just take the revenue function and plug in 16.7. The revenue function is this thing right here. Okay, that's the thing I'm highlighting in blue. So you would just do negative 60 times 16.7 squared plus 2,000 times 16.7. Okay, then just do that on the calculator, then you got what that maximum revenue is. You can do that in one step. So that would be negative 60 times 16.7 to the second. And then plus 2,000 times 16.7. And I can show you kind of visually how you can tell this is right. So it looks like that revenue is going to be, the revenue, the maximum revenue, is going to end up being about $16,666.60 if you round that off. So that's the idea. So the idea with that is the vertex is where the maximum was. That's why I used negative B over 2A like that to get that. Okay? All right? So let me ask this real quick. Nobody answered this a minute ago. How do you find the revenue? What's the formula? XP. XP. You got to get that down. So that's how I found the revenue. And then, after I graph that on the calculator, to find the maximum, you have to know the vertex. What's the formula for finding a vertex? That could be over 2A. So those are two formulas you have to know. If you don't know, then what are you going to do? Miss the problem, right? Okay, those are fundamental things you have to know. Okay? Okay, so on the next page, I'm going to just show you kind of how to check this. I don't really need to write anything on here. So if you were to go through and do this, you can try this. If you got the same graph that I had, well, here's the way you can do technology. Okay, and you should learn how to do this. Okay, so if you got your graph up the way I've got there, if you follow these keystrokes, you will get the same answer we did algebraically. So what you would do is go second, trace, then go down to the minimum. So second trace, or I'm sorry, the maximum. Go down to option 4 maximum. Press enter. Okay, like that. Now it's going to ask for a left bound and a right bound. A left bound just means get a little bit to the left of it, which is good. Right bound means get a little bit to the right of the vertex. Okay, so there's no exact place that has to be. So that's good enough. Okay, that looks like a left bound, or you can move it in a little bit and then just press enter. Usually a line comes out. Then when you do the right bound, just use your right cursor key and keep moving until you know that you're to the right of that vertex. So right now I know I'm to the right of it. Press enter. Okay, guess will come up. When guess comes up, press enter again. Let's see if we got this right. Okay, I've already forgot what we got. Did we get 16.7?
Yeah.
Yeah, did we get like 16,666?
Yeah.
That's the easy way to do it, okay? Their technology can find that for you, okay? But you want to know how to do that kind of both ways, but that's a real quick way to get that done with your TI calculator then. Okay, so let's finish up this last thing here, and then we'll take a break. I want to go ahead and just finish this. So this one is break-even analysis, and this one I've already given you the revenue. So I've given you the revenue, and I've also given a cost function on this. So what we're going to do is just do a real rough sketch of the revenue. Okay, we're going to again do this on the calculator. Okay, so I'm just going to start over again on the calculator and go to y equals, clear off what we have, and then put in the revenue function. I'm just going to put it in the way I have it. I have x, and then parentheses, 75 minus 3x. And then we're going to graph this. Now this one says you want to go from 1 to 20 on your x-axis. Okay, so you want to start by putting that in. Okay, the window, we're going to do this. Okay, we're going to go 0 to 20, because that's the problem says 1 to 20. Let's go 0 to 20. And let's see, might have to change the values. Again, to get the y value, look at your table of values. So if you go second graph, just start looking at your table of values. And notice now on this one, the y values are in the hundreds. So a good way to scale this would be like this. Since all those y values are in the hundreds, then I would probably suggest that you go 0 to 1,000. And then maybe scale that by 100 like that. Okay, so that would be a good viewing window to put in your calculator, is that then? Okay, if you get that put in, you type graph, that's what your revenue function looks like. It's a parabola, just like the last problem. That would give you a good picture of that revenue function then. Okay, so you just put the function in, get your window set up, and then we'll just kind of sketch a graph. So on this problem, all you need to do is just label the x-axis 5, 10, 15, 20. That's how we did the x-axis. And this one is memory chips. So we would have to say x memory chips. You want to label what everything means, read the problem and get that information. And then this is your revenue, like that, okay? And we made this go all the way up to 1,000, so we could just go 1, 2, 3, 4, 5. That's even good enough if you just put 500 like that and just sketch it. You don't have to get the points perfect, just kind of get a good ballpark on that. Okay, break-even points, what we're going to do is break-even points occur where the revenue is equal to the cost. Okay, and what we're going to do on this, we're going to do this totally on the calculator. I'm not going to do this one algebraically. Okay, so what you want to do on your calculator is you also want to graph your cost. So we've already got the revenue in. The cost function is the 125 plus 16x. So you go to Y2 and you put in 125 plus 16x. Okay, that should be a line that should cross that revenue in two places. That's typically what happens. Okay, so you want to just get those two functions in. Same window. This window should work great. Type graph, and then that's what you have. Okay, so then what I want you to do on your graph, just estimate this. Just kind of draw a line through there. Okay, and then that is your cost like that. Then I'm going to show you how to get these intersection points for your break-even points. So you want to follow what's in this information here in this rectangle. So after you get everything graphed, just do exactly what this tells you to do. You start off by going second trace, then going down to where it says intersect. Okay, so get to the intersect. Just follow what this says, press enter. What will usually happen is a cursor will come on one of the curves. Get that close to the first intersection point. So I'm just moving that so it's relatively close to the first intersection point. Okay, then I press enter. What should happen is another cursor goes on the red line. Press enter. When it says guess, press enter. And then what will happen is it'll do the work for you. So that first break-even point is going to be this. I'm just going to have you record these. So that is about 2.4, comma, 163.6. So that's break-even point number 1. Okay, that's what that means. Okay, what you have to do is you have to start this over again. So just do what's in here. I'll write that down for you. Second trace. Intersect is option 5. Okay, now this time move your cursor until you get relatively close to the other intersection point. Just move it over until you're pretty close to it. Okay, I think I'm probably close enough. I just recommend you get pretty close to it. That's probably good enough. Press enter. Now the other cursor will come out on the cost function. Press enter again. When it says guess, press enter again, and then it should be blinking on that other intersection point. So that point right here is 17.3 and then 401.02. Okay, so those are your break-even points. Now what that means is a break-even point. What does a break-even point mean? Do you guys know that?
Intersection.
It means the revenue and the cost are what? The same. Are you making any money? Are you making any profit? No. Are you losing money?
No.
No. So a break-even point just means you aren't gaining money or you aren't losing anyway. So what would happen is this. And what I want you to do on your graph is just write a note to yourself like this. The part right there that I shaded, that would be where your profit is. And then the parts that I'm going to highlight in blue, that would be where your losses occur, like that. Okay, so those are losses like that. So profit is going to occur in between these values. Profit will occur between 2.4 and 17.3. Okay, that's just the X values of the break-even points. So in between production of 2.4 and 17.3, that's where you're making money. Everywhere else you're losing money. Does that make sense to you? Okay, what's the formula for revenue? XP. What's the formula for a vertex? That could be over 2A. So you guys need to know that. Okay. All right, so that'll wrap us up. Let's go ahead and take a 5-minute break. And we come back. Let's come back at 10 after, I guess. And then we'll do as much as we can on 2.4.